So in this chapter, we're going to be setting up our environment. We're going to install MySQL on Windows, on Linux, and we'll install XAMPP, which is a combination of MySQL, Apache, and PHP. And we'll also look at PHPMyAdmin and MySQL Workbench. But before we do that, it's really important that we talk about some of the principles of database design that are pretty much mandatory if you want a reliable and functional database. And we're also going to talk about something called normalization. And there's just certain ways that you need to build your database and build your tables. So we're going to talk about that. I want to talk about something called relational model rules, which are basically some guidelines to go by when you're creating a database, a relational database. Alright, so these are very basic. Each column value must have a single value only. And this isn't always followed, not by any means. There are some database structures out there that are just crazy. But a single value should be in a single row. You shouldn't really store, for instance, comma separated values. You shouldn't put them in one row. If anything, create a new table for that data and then separate the rows. All values for a given column must be of the same data type. Alright, so you don't want a column that has an integer and then in another row in the same column has a varchar. Okay, so you want to keep the same data type for a given column. Each column name must be unique. Alright, so you definitely want to make sure you have unique column names. And what I mean by column name, for instance, in a user's table, you may have a column name called first name. You might have one called last name, email. Those all have to be different. The order of the columns it's basically insignificant because you're going to use your application to sort the order of your records. You don't really need to do that in the database. No two rows in a relation can be identical, and the order of rows is also insignificant because you can manipulate that through code. Alright, so functional dependencies. A functional dependency describes a relationship between columns within a single relation. Okay, so a column is dependent on another if one value can be used to determine the value of another. For instance, if you have a customers table, your customer ID value should be able to you should be able to get that to get the, let's say, the first name value. Okay, and actually I said that before I even saw this example. So first name is functionally dependent on ID because ID can be used to uniquely determine the value of first name. Okay, that's what functional dependency is. Here's some common design mistakes. Tables with too many fields or with fields that do not relate to each other. So your fields should definitely relate to each other per table. If you have a customer's table, everything that's in that table should relate to the customer. You don't want to have product info inside of the customer table. Too many tables with similar data. You don't want that. You don't want repeated rows. Okay, so you don't want two rows that have the same exact information. That's why it's really important to have a primary key most of the time. Using comma separated values or multiple values in a single row is another very common mistake that people make. Poor naming conventions. So you want to stick to a convention. If your tables have camel case, you want to stick to that for all your your fields. If they have underscore separated words, then you want to keep that throughout your whole database. Poor or no planning is obviously a big mistake. You want to visualize your data before you actually create the database. And non-normalized data. There are some things in normalization that I think aren't mandatory, but for the most part it should be normalized. So that brings us to database normalization. Okay, so normalization is the process of organizing the fields and tables in a relational database to minimize redundancy and dependency. Okay, so you want to make your data as independent as possible, and of course avoid redundancy or repetition. And this can involve dividing larger tables into smaller tables and defining relationships between them, which I'll give you an example in a few seconds. The objective of normalization is to isolate data so that actions in a field can be made in one table and then propagated through the rest of the needed tables using properly defined relationships. So in normalization we have what's called first normal form, or 1NF, second normal form, and third normal form. And basically it's just a structure that is to be followed when creating your tables. So first normal form includes no repeating or duplicate fields. Each row should contain only one value. Each row should be unique and identified by a primary key. Alright, so what I have here is an example. In this first table in red, this is wrong according to the first normal form. And the reason is this is a customers table, and we also have membership. We have a customer, we have membership. If we have this all on the same table, then we're repeating customers here. Okay, we have John Doe twice just because he has two memberships. No matter how many memberships he has, this should not repeat. Okay, this should not repeat twice. Down here is the solution to this problem. Okay, so the solution is to break this into two tables. One is the customers table, which just has the ID, which will be unique. It'll be the primary key of the customers table. You can see up here it repeats, so it's definitely not primary. It's not unique. And you can see we have two users, just like we do up here. And then we break another table. We break this into a membership table as well, which has a primary key per customer membership. Okay, so the customer ID. So John he's a member, and he has a silver membership and a gold membership, so it's showing that here. But we still have a unique primary key, even though John is in this table twice. Alright, and then we have Steve, which has a gold membership. Alright, so this is a solution to this problem. So second normal form should have the first normal form formatting. Also, all non-key fields depend on all components of the primary key, and we'll see an example of this in the next slide. And we also want no partial dependencies. Okay, so here we have a customers table which has the ID, the user's name, the membership ID, and the membership. Alright, now you don't want to have the membership ID along with the customer ID in the same table. You can break this up so that you have a customers table that only has the customer ID and the customer name, and then your membership table will have a primary key itself in addition to the customer ID and the name of the membership. Alright, so this here, this membership ID has its own table and has its own primary key. So that's a 2NF example. Third normal form should have 1 and 2NF formatting. In addition to that, every non-prime attribute or column must depend on a primary key. Alright, so another example here. Now this is something that I feel isn't mandatory. Basically, we have a table, a customers table, has a primary key, has the customer name, and it has the customer's address, street, city, and zip. But if we're going by 3NF, basically we want to take the zip code and create a new address table and use the zip code as the primary key. then we can just pull the customer, and we can see the customer's zip code, and then we can pull the address information. Alright, this is just one way of doing it. Personally, I would keep it like this and keep the street and the city and all that in the customers table, unless there was just a lot of address information. But I think this here is fine, even though it says wrong, but that's just going by 3NF. So that's what normalization is, and just basic principles when creating a database. A lot of them are common sense. You don't want a repeat of the same row with all the same information. Naming conventions, obviously you should stick to one naming convention, things like that. Alright, so next up we're going to get everything installed, and then we'll finally create our database.